Okay, this is problem 182, and it's a, if you look at it, it is a r theta, but it also looks like it might be a tangent normal because it's also given speed. And it turns out that what I'm going to do is write down what they tell me. It's not a time spanner, so I'm not going to integrate anything. So I'm going to write down what they tell me, and what they say is that the speed is 30. So I know that the velocity is equal to 30, and it'll be in the tangent direction. They also talk about wanting theta dot, so I'm also going to write down the formula that has theta dot in it, which looks like this: r dot ur plus r theta dot u theta. And so what I'm going to do is equate this vector. So for example, here I don't know what r dot is, and some of the students were saying that they would like to write this in terms of the angle theta and then take a derivative. I don't have any problem with that. I think that might be a little difficult, so I'm going to avoid it. But anyway, if I add these things or count how many things I have unknown, I don't know r dot, I don't know r, and I don't know theta dot. But this is a vector, and so the vector's got two components, and I'm going to be able to get two equations by setting this vector over here equal to this vector here. I'll show you what I mean in a second. Now I need another equation, which is the r, and so you cannot solve for the r using a velocity equation. You don't solve for positions using velocities. So what I'm going to do is I'm going to look at the geometry down here, and I'm going to look for a formula for the distance r. And in class the students wanted to use law of cosines, and there's nothing wrong with that. I don't remember the law of cosines, and so I'm going to use the law of sines. So I look at this and I realize that this is an isosceles triangle. I'm just using whatever geometry I remember from high school, basically. So it's an isosceles triangle, so this angle theta is the same as the angle over here, theta. So this angle is also theta. Now the sum of the angles inside all have to add up to 180, so this angle right here is 180 minus 2 theta. So once I know theta, I know all of these other angles as well. Okay, so I know that this angle, let me get a different color, this angle right here has to, the black one plus the blue one have to add up to 180, so this angle here actually has to be 2 theta. Alright, so far so good. Okay, so I need to find out where the u r, the u theta, and the ut's are. So I'm going to just draw a picture on here. So we'll kind of zoom in a little bit. The ur is found by starting, because I'm measuring r and theta from here, so I'm going to draw the line straight up from that origin, straight out, and that is my ur direction. I want to find out where it is, so I'm going to draw a horizontal line. This line and this line are parallel. So if the angle down here is theta, this angle right here is also theta. To find the u theta, I have to rotate 90 degrees from the ur. And so counterclockwise, because that's the direction theta is being measured. So I'm going to draw a line here, and this is the u theta direction. Alright, so I'm going to draw a vertical line here. So this angle right here is also theta. Okay, so far so good. Now, I need to find the tangent and the normal. This point right here, let's do this in yellow. So this point right here is the origin of the path that the car is on. So that's the center of the curve. So this direction is inward. So that's going to be my UN direction. And perpendicular, or tangent to the curve, then is going to be this way. And that's going to be the UT. Now, what I taught you in class is to get the UT first, though I should have done that. But anyway, hopefully you realize that I've got that. So anyway, I'm going to extend this line. I'm looking for some directions of this thing. So I'm going to extend this line down here. That's just the UT direction. And let's see. This angle between here, let's extend it up. Right, so that's an extension of this line right here. So this angle right here is 2 theta. Right, so if that's 2 theta and the blues are theta, then this angle right here, I'm running out of colors, the angle between these two right here is theta. Okay, so if that one's theta, then the angle between the yellow and the blue over here is theta. Okay, so that was the angle that I was struggling with this morning in class. But anyway, so now I have the angles. Now let's proceed with what I was going to do. Okay, so now what I have is I've got this vector right here, and it's got to equal this one here. So I'm going to use what I did in, or what you learned in statics, and I'm going to convert these vectors into the various components. Okay, so what I know is that this yellow one here, right here, has a length of 30. So this vector here is 30 in the UT. It's this one here, 30 UT. And what I'm going to do is break that down into the directions of UR and U theta. So what I'm looking for is this. I'm going to take this, think of the 30 UT as a force, and I'm going to drop that force down, and I'm looking for this component right here. So it's like it would be, if this was a force, that would be, I'm looking for the component of that force in the UR direction, and I'm looking for the component of force along here, which is in the U theta direction. Okay, so if this angle, the black angle, is theta, this one here is theta. So what I have is the component along the UR is going to equal 30. That's the magnitude of the force. Let me put it in black so you can see here. Okay, so the magnitude of force, so I'm looking for the distance. That would be magnitude 30 times the sine of the angle theta. And he is pointing backwards inward, which is opposite to UR, and that's how much he is in the UR direction. The 30 UT is also got a component right here. So I want to know what that is, and that's going to be the magnitude 30 times the cosine of the angle theta, and he's pointing in the U theta direction. So that would be a constant. U theta. did is I broke down this 30 in here. And the 2, I broke it up into components, UR, U, theta. So that is supposed to be equal to R dot in the UR direction plus R theta dot in the U theta direction. Now what I need to find is R. And so I'm going to use the law of sines because I remember that one. The law of sines would be R is to the sine of 180 minus 2 theta as 20 is to the sine of theta. Okay. So now what I've got then is I can solve the last equation right here for R. I can put that R into this formula, and then what I'll do is I will take the UR piece over here and set it equal to the UR piece over here, and I will take the U theta piece and set it equal to the U theta piece right there. So the equations that I have are the following. We have R equals 20 sine of 180 minus 2 theta. Probably should use a calculator instead of writing all this out, but okay, so there's my R. And then the other equation is minus 30 sine theta equals R dot and 30 cosine theta equals R theta dot. Okay, so to finish this is just a matter of using a calculator and calculating the value of R and the R dot and theta dot. Since they tell me that the theta is 30 degrees, then I can just plug everything in and grind it on out. So the problem that I was having this morning was finding the angle up here, and as half the people in class were telling me, it was 30 degrees. And so anyway, that's it.